Hola a todos, buenas tardes. Ya después de unas muy interesantes charlas, continuamos con nuestras actividades del GIS-DAY. Y bueno, sin más preámbulo y una disculpa por el pequeño retraso, les presento al doctor Chris. Chris es doctor en Ciencias Biológicas por la Universidad de Queensland y básicamente él y su equipo trabajan en el manejo de ecosistemas oceánicos, para lo que utilizan estadística avanzada para tratar de darle un sentido a esos datos y, de la mano de las agencias de gobierno y no gubernamentales, coadyuvar, ¿no?, en el manejo de los recursos naturales. Un ejemplo del trabajo que hace Chris y su equipo es el que tiene que ver con el monitoreo de la pesquería de atún. Él tiene su base, como les comenté, en la Universidad de Queensland, en Australia. Así que, sin más preámbulo, les presentamos la charla de uso de datos y modelos espaciales para impactar la gestión costera. So, Chris, thank you very much. Well, it's a pleasure to hear from you today. So, go ahead, please.
Gracias, buenas tardes. So, yes, I'm Associate Professor, sharing screen. Associate Professor Chris Brown, and I was working in Queensland until very recently, and now I live in Tasmania, at the University of Tasmania, where I work on fisheries. So I moved from a warm tropical place to a cold temperate place. So today I want to talk to you about why do we do spatial science. And I think most environmental scientists are doing this job because they want to make a difference to the world and a difference to nature. So I was asking myself, how can my work make a difference to the world? And I want to encourage you today to think about that question and think about your theory of change. How is your science, your spatial science, making a difference? Now, it's traditional in Australia that we pay our respects to the Indigenous people whose land that we work on, and acknowledge that across the world many Indigenous people have been forcibly removed from their land. So I'd just like to pay my respect to the Palawa people of Tasmania, the place where I live and work, and extend that respect to all Aboriginal and Torres Strait Islander peoples and Indigenous peoples around the world. So this is the big question I want to ask today. How does spatial science benefit nature? And then what can we do as scientists so that our work has more benefit for nature? And it's a good question to ask, and there has been some criticism and controversy in the academic literature about this. So some people have asked whether there's too much modelling, too much spatial science happening and not enough fieldwork happening anymore, and that this means that conservation science doesn't get enough on-the-ground information. And other people have argued that we're spending too much of our scientific time making maps and not enough of it doing local studies. So I think it's good to ask, when we're making these maps, how are they making a difference and how are they having an impact? So what I want to put to you today is this idea of a theory of change. So when you're doing your research, a theory of change describes how your science will connect with management and policy and make a difference on the ground for conservation work. This particular theory of change here comes from some work we did a couple of years ago, where we were thinking about ecosystem assessments, where you're trying to map the health of an ecosystem and how does that link back to management and conservation. And so today, through the work that we've been doing with my team in Queensland and Tasmania, I want to talk about the different theories of change that we've been using. So I need to acknowledge my project, which is the Global Wetlands Project. It's a team of researchers in Tasmania and Queensland and across the world working on coastal wetlands. So they're these amazing ecosystems that we have along our coast that support a lot of biodiversity. So just to explain why you should care about coastal wetlands. So these include ecosystems like seagrass meadows, mangrove forests, which Mexico has a lot of, salt marsh ecosystems, and kelp forests. And they're really important habitats because they're really very important for fisheries species. So they bring a lot of value to people and food and sustenance, and also cultural value. A lot of these ecosystems, like mangroves, can capture a lot of carbon from the atmosphere. So they're important to help us mitigate the effects of climate change. And they're also important habitats for biodiversity, and help stabilise the coastline and protect us from storms. So in the Global Coastal Wetlands Project, we're doing a lot of different types of spatial science, but we're really focused on this question of how is our spatial science helping conserve coastal wetlands. So the first theory of change I wanted to put to you, for you to think about, is what I just call a classic theory of change. And this is the way a lot of scientists still work. So we think we might do some science, we'll publish that in an academic paper, and then hopefully people will read the science and use it. And then we started to realise, the scientific community in general, that not a lot of the managers and the general public are reading the scientific papers. So I call this the read it and publish plus method, which is kind of the same really. You publish, but then you do some media, you do some presentations, maybe you go on X or Instagram and share your work, so you try and communicate your work more broadly. And this method can still work for communication. So I wanted to talk a bit about some work that my colleague Fernanda Adame led. She grew up in Mexico City, but she now lives in Brisbane, in Queensland, and works with the Global Wetlands Project. And Fernanda spends a lot of time going back to Mexico to do work on mangrove ecosystems and mangrove conservation. And she's really very passionate about the conservation of those ecosystems. So she was working in Mexico, and she was visiting these different sites here to collect sediment cores. So for mangroves, they can store a lot of carbon and prevent that carbon going into the atmosphere. And for mangroves, unlike rainforests, a lot of the carbon they store is in the soil underneath their roots. So it's not in the trees and leaves. There's a bit of carbon stored there, but much of it's in the soil. So Fernanda spent a lot of time travelling around Mexico to key mangrove hotspots and taking cores to measure how much carbon is in the soil. But what she noticed was that in the government's national policy that's called the Nationally Determined Contributions, so their national policy on how they're mitigating climate change, and this is the documents that most governments submit to the United Nations to report their climate change emissions and report what they're doing about climate change. So Mexico's document, they have mangroves in there, but they don't count the carbon that's stored in the soil. So this means they're missing a lot of the value that mangroves provide to Mexico in terms of preventing carbon emissions. And so Fernanda was worried about this because it means when the government is looking across places and looking across different ecosystems to think about where can we reduce carbon emissions, they're underestimating the benefits that mangroves provide. Fernanda came to me and she had this spatial information of where carbon was, how much carbon there was stored in mangroves across Mexico. And then she also worked with government to get information from remote sensing from satellites on how much mangroves were being lost in Mexico. And then I worked with her to develop a model that brings these two types of spatial information together so we can project carbon emissions, assuming that mangrove loss continues at its current rate in Mexico. And so the blue line here shows using Fernanda's data on the carbon in the soil. The blue line shows how much carbon emissions are being created in Mexico from mangrove deforestation. And the red line down the bottom there shows how much carbon emissions are being created if you used the government's method at the time, which ignored the value that mangroves provide. So there was basically a 31 times difference, so that they were underestimating the emissions from mangroves by 31 times. So that's since been corrected. And what this means is that there's more attention now on mangroves, and it opens up pathways for mangrove conservation because they're now recognised as important for helping reduce carbon emissions. So in that project that we did with Fernanda, the theory of change there really was, we'll do this science and then we'll publish it and share it, and we hope that has an influence. So the second theory of change I want you to think about is what I call the open data theory of change. And Esther has told me that this morning you heard from the Global Fishing Watch. So this is a little bit like what they're doing by creating open data. So this theory of change, we think we do the science, we publish it, but then we also make the data that we've created freely available. And by having that data freely available out there, it means more different people can use it, and hopefully policymakers and managers are able to access that data and use it, and that will then influence their decisions they make about the environment. So I want to give you one example of where we've tried this theory of change in our Global Wetlands project. And for this one, we're going to look at seagrass ecosystems. So there was a famous study in 2009 that compiled as much data from across the world they could find on the rates of seagrass ecosystem loss. So we know that seagrass ecosystems are very important particularly for coastal fisheries. And we know that in a lot of areas we've lost a lot of seagrass because seagrass is sensitive to pollution, it's sensitive to fish farms, and it's sensitive to some types of fishing like destructive fishing. So we knew that in certain places around the world we were losing a lot of seagrass. But no one had put that information together to say across the globe how much seagrass are we losing. So this study pulled together information from hundreds of other studies across the globe, and you can see them there on the map. And they estimated that seagrass was being lost at this rate of 7% per year. So if you think about it, 7% is a very high rate. You know, it would only take you 10 years, at 7% per year, it would only take you 10 years or so to lose all the seagrass in the world. So we wanted to update this study to see if that was true. You'll notice on the map that a lot of the parts of the world are missing. So that this earlier study was very biased to North America, Europe and Australia, and a lot of the other parts of the world where there's seagrass, they didn't have any data. And we also wanted to use more advanced spatial analysis methods that we have now to analyse the data because we weren't sure if this 7% statistic was accurate. So this work was led by Gillian Junick, who works in Canada now. So Gillian and our Global Wetlands team, we did a lot of work looking through the literature and old PhD theses and so on to find studies that had looked at how much seagrass was there in different places and how much faster it was being lost. And so you see on the map here, all those yellow dots are the new places where Gillian and the team found data for seagrass. So we've managed to fill in a lot of the world, the seagrass world. Obviously still missing parts of South America, but now we have data from Africa. We have a lot more data from Southeast Asia and Australia as well. So this can give us a better idea of how fast seagrass was being lost. And then rather than just averaging rates of loss, we use some more advanced spatial analysis techniques. So I used it, if anyone's familiar with it, generalized additive models. And those methods are useful because they allow us to look to see if change is non-linear. So rather than assuming that seagrass is just going down all the time, we could see if it's going down faster sometimes or even if it's coming up. And the other thing that we did differently from the other study was we didn't think that seagrass would be being lost at the same rate everywhere around the world. So we analysed the rates of seagrass lost by different regions. So you see, for instance, what we found was that there was a lot of variability. So in some parts of the world, like Europe, which is in purple there, back in the early 1900s, there was very rapid seagrass loss largely to water pollution and the spread of disease. But now they've been protecting with seagrass and trying to restore it. And you see there's a little uptick there in more recent years. So Europe now, seagrass is actually recovering. Parts of North America, there's been a lot of loss and it's not recovered. And in parts of Southeast Asia and Australia, the rates of loss haven't nearly been as extreme as other parts of the world. So what we found was that we can't just say there's been 7% per year loss of seagrass across the globe. It varies a lot depending on where in the world you are. And so just to summarise some of that information, we estimated that about 19% of the world's seagrass that's been surveyed has been lost. And the primary causes of that loss are pollution and coastal development. So this sort of information can help put seagrass on the radar of policymakers and governments and help them focus on areas where seagrass loss is at its greatest and just get more attention to this important ecosystem because people won't act on protecting the ecosystem unless they know that it's in trouble. So this information helps to show that. Now, there's still a lot of parts of the world where we don't have any seagrass data and we're not sure how at risk seagrass is. So then our postdoc, Mr. Tershwell, followed up with another study where he took the spatial information that we had on rates of seagrass loss, and then he built statistical spatial models to try and predict seagrass loss based on the species of seagrass that grows in different regions and the threats to there, including water pollution and destructive fishing practices. And so using that information in a GIS, we can bring that information together to predict risk of seagrass loss across all areas of the globe, even areas where we don't have data. So this information is important because it helps fill in gaps on seagrass loss and can help countries prioritise where they monitor to see, find those areas where they're losing seagrass and then take conservation action on that. So all of the data that we've created for these projects, we've made freely available. And now we're finding it's being picked up by conservation organisations like the World Wildlife Fund. So that was my second theory of change, that open data science can change the world. So I want to skip on to my third theory of change now. And in this one, I propose that rather than just doing the science and publishing it, that we should co-develop the science. So that means working with partners. They might be in non-governmental organisations, or they might be in government, they might be in industry, or maybe even in local communities. And working with those partners to develop your science, to develop the research question, and then doing the science so that you have an end user that can use that science and hopefully have a positive impact on nature. So for this third example from the Global Wetlands Project, I wanted to talk about work we did with the Global Mangrove Alliance. So the Global Mangrove Alliance is an alliance of a whole heap of different organisations, including the IUCN, the World Wildlife Fund, the Nature Conservancy, Conservation International, and more local organisations are joining that as well, and universities are partners as well. They actually have a branch in Mexico now, so I encourage you to look that up if you're interested in getting involved with mangrove science and mangrove conservation in Mexico. So part of their goal is to help raise awareness about mangrove conservation, and they want to do that one way they do that is by setting these goals. So they set these global goals that for the Alliance, we're going to aim to halt loss of mangroves, restore half of the mangroves that have been lost, and then double protection of existing mangroves. So we wanted to work with them to look at, is it possible to achieve those goals? And the way we approached this work was we engaged with the NGOs, the non-governmental organisations. So this is all conservation organisations like World Wildlife Fund. We engaged with them with the start to say what science can be helpful for you, and we co-developed that science, and then we published it, and that science along with the NGOs. And now that science is being picked up and used by the Global Mangrove Alliance because that's the way we designed it. So there's been a lot of work arguing that global targets for ecosystems are very important because they help consolidate global action. They can help raise awareness about an ecosystem and generate funding and government policy at the high level that then hopefully filters down to impact at the local level. So you may have heard about the Convention on Biological Diversity. That's an international convention that a lot of nations are signing up to set certain targets for the protection of the Earth's ecosystems. And so the idea is that once countries have signed up to these conventions, they're then encouraged to achieve those goals by taking action within their countries. So I didn't want to talk a lot about today, but we've just had a paper out led by our postdoc, Christina Bulow. And if you want to get a screenshot, there's a link there at the bottom to a nice blog she wrote about the post. But in this article, she sort of explains how these global targets for biodiversity can be linked down to action on the ground to make a difference. And she really takes, again, this focus on a theory of change. So it's one thing to have the global target, but we then also need to link that to how a particular country is going to have take actions to achieve those targets. So Christina Bulow did a lot of work on this question of global targets and what the countries need to do. So working with the non-governmental organisations, one question that became important was that we need to know, say we have a target for doubling mangrove protection by 2030. We need to know how much do we need to do each year to reach that target. So how fast do we need to act to reach our targets? And then that will help determine what funding the World Wildlife Fund needs to raise to support that conservation effort. And mangroves are a nice place to work for this type of question because there's so much spatial data on rates of loss. So there's been a lot of mapping done with satellites to estimate back 20 or more years, how fast are we losing mangroves? So Christina's very good at spatial modelling, so she can take that information from the past and use it to project forwards to 2030 or 2050 to say how fast are we losing mangroves, and therefore how fast do we need to protect them to prevent that loss and reach these targets for conservation. This can then inform what conservation needs to do, how much funding they need to raise, and where do they need to raise that funding. And so another part of this question is looking at where do we need to do conservation. So she took the rates of mangrove loss from that remote sensing data, and then she also took rates of seagrass loss from that last paper I presented. And then she looked at two specific goals. So one was how much protection can we achieve, so protection of these ecosystems that prevents loss, how much can we achieve by 2030? And then if we're doing restoration, it might take a bit longer to get going, so how much can we restore by 2050? And then she considered two targets for those, for protection and restoration. So there was what we called an intermediate target, which is protecting 30% and restoring 50%. And there's what we call the ambitious target, which is protecting 50% and restoring 90%. And so the ambitious target might seem a bit too ambitious, much harder to achieve. But what we know from working with organisations like WWF, who are going out and trying to raise funding from governments and from private donors, is that the ambitious targets really help them talk about and get the donors excited about funding conservation. So we want to include this ambitious target in there because it helps motivate action on conservation. If people would see how much we can achieve if we have the right funding, it can help motivate a lot more action. And so, yeah, we're interested in recovery of the ecosystem. So she used that spatial information and combined it into a spatial model to project forwards how we would achieve those goals. And then she was able to look at, for different countries in the world, what types of actions should they focus on to achieve those goals. So the maps here, the top one shows mangroves and the bottom one shows seagrass. And then basically the countries that have more green, these are countries that need to focus more on restoration to meet these global goals for conservation. And the countries in blue are ones that need to be focusing more on protection. So where you have green countries, they're generally countries where they've lost a lot of their mangroves or the seagrass in the past, but now the rates of loss have slowed. So they need to do restoration to get the area of mangrove or seagrass back up again. Whereas the countries in blue, or the habitats in blue, are ones where they're still losing a lot of seagrass or a lot of mangroves at a fast rate. So the most effective way to reverse that loss is to protect those ecosystems, which might be by creating protected areas or the seagrass taking other actions on pollution that will then slow or reverse the loss of those ecosystems. So this was useful because we see that a lot of parts of North America, restoration should be the focus for mangroves, for instance, whereas in parts of Southeast Asia, like Indonesia, we need to have a mix between restoration and protection to achieve those targets. And there's a contrasting situation for seagrass. So, for instance, in North America, seagrass, we still need to focus in protection because we're still losing it at a fast rate. So that was my third theory of change, which was really about working with NGOs to deliver some science that is useful to them. And so those kind of maps and that kind of information helps them go and raise funding for mangrove conservation. So Christina and I went on to do some more focused work with the World Wildlife Fund, and they asked us to help them develop a 10-year strategy plan for blue forests. So they define blue forests as these coastal wetland ecosystems, so kelp forests, seagrass, mangroves and salt marsh. So they want to develop a 10-year plan that would help them focus their conservation efforts in particular parts of the world where blue forests are most at risk from loss and where blue forests provide the most value to local communities. So, for instance, in parts of Indonesia, the mangrove forests are very important because they help shelter the coastline from storms, and they're also important habitat for fishery species. And Indonesia is still losing mangroves at a rapid rate to conversion for agriculture, cattle farming, and aquaculture, shrimp ponds. So areas like Indonesia might be places where WWF wants to focus, because by protecting those mangrove forests, it will bring a lot of benefit to local communities and help prevent loss of those. So they want to know where else in the world should they be focusing their effort on these blue forests. So this information then helps them go out to donors and get the donors, the people that are funding the conservation, really excited about what they're doing. So we used, to help them develop this 10-year strategy plan, we used all of that spatial information I've just told you about and brought it together for the globe. And that sets their kind of conservation objectives at a high level. So I just wanted to mention the work that our postdoc Hiram Villarreal-Rosas is doing in Marismas Nacionales in Mexico, where she's now working with WWF on a much smaller scale. And this is not using the global information, but using locally available information that is much better information for that location. So once WWF identifies that parts of Mexico are really good places for blue forest conservation, then Hiram can work with them to look at exactly where do they do the restoration within a particular mangrove forest. So get in touch if you're interested in hearing more about the work that Hiram is doing. So Christina Bulow took all this spatial information, and using the R program, we developed this app for the World Wildlife Fund, and you can see it on the link there on the screen. And so this app lets them explore anywhere in the world, the different blue forest ecosystems and the information that's currently available about them. And it lets them look at how much of those ecosystems occur in different parts of the world, what are the main threats, and what are the main values like carbon storage or fisheries or coastal protection. So this information is really useful for World Wildlife Fund to then look at where do they want to invest conservation funds. And then the other thing we brought into that app, we were working with a team called Finance Earth, who specialise in the financing of conservation. We're actually able to access information on where there are already conservation projects happening on the ground. And so we can link that information together to say, this is a place where there's conservation projects happening right now, but they need more funding. And in this place, it's going to be attractive for donors because, it's an area with high rates of loss, so it needs conservation investment right now. And there's projects on the ground that are ready to go. They just need that investment. So this global information is coming together and helping WWF inform where they do their blue forest conservation. So they're the main theories of change. I just wanted to talk about what's next for our global wetlands project. So in the future, we're going to be doing a lot more work on climate change. Sea level rise is obviously an important threat to these coastal habitats because they're very sensitive to sea level. So we've been doing a lot of work on sea level rise. And Hiram and Fernanda are still doing work in Mexico and now Belize and Colombia as well around mangrove restoration priorities for those countries and working with the World Wildlife Fund to inform their restoration actions. So just to sum up the theories of change, my first one was a classic one that most people are trained in, which is just publish your science and hopefully someone will read it. Then I call the classic plus, publish it, hope someone will read it, but also do some media and presentations to tell people about it. An alternate way to do your science is make sure the data is freely available, and then people will hopefully use that data to inform conservation. I think a more effective way is to engage with partners from the start, so working with the non-governmental or conservation organisations from the start, so that you're asking science questions that are useful to them and develop that science with them. And then for the early career researchers, I just wanted to add a final theory of change for you to think about, and that's to become a policy advisor. So if you're still studying science, if you're doing your undergraduate or doing your PhD or master's, not all of the science you do has to have an impact on nature. Sometimes science is just there for scientists to learn, sharing it between scientists who are learning more, and you're learning more. But I would encourage you to then go out and take what you've learned and work with communities and work with policy advisors, policy makers, to advise on what they're doing in whatever area of research you're working on. So if you'd like to do more in this space, what can you do? I think if you're an early career researcher and you're just starting out in science, every time you're doing some science, look for the policy relevance of that. So who are the people that will care about my work, and what types of actions in nature can it inform? I encourage you to read very widely. Read scientific literature, but you should also read policy documents, read the news, and be up to date with current events. And showing up to events like this to meet people and network is also really helpful for that. And then if you have opportunities to talk to people working in conservation or management, make sure you ask them lots of questions and use active listening. So really try and understand what are the problems they're facing today, rather than just telling them about what your science is. Try and understand what problems they have and what do they need help with. If you're more senior in the university or your organisation, if you're supervising people or you're senior in the institution, there's some things you can do as well. So when you're planning a project for a grant, think about your theory of change. How is this project going to make difference? If you can, for students, encourage for them to do internships during their studies. So internships with a conservation agency or with government can be a great way for them to learn more about how their science can help. And of course, put a lot of value. Historically, we've not valued applied science, but I think we should be putting more or as much value on applied sciences as other types of sciences. So hopefully for institutions, we can ultimately be training people to go out and become policy advisors. So before I finish, I just want to thank the Global Wetlands team. I've had the pleasure, we've been going for over 5 years now, and I've had the pleasure of working with so many students, conservation organisations, and international researchers. So I just wanted to thank a lot of those people. And I want to thank Esther for inviting me to present today. It's a real pleasure to have the opportunity to present from Australia all the way over to Mexico, and hopefully I can come and visit you at some time. So if you're interested in any of my work, feel free to email me at the University of Tasmania. I do a fair bit on social media, on Instagram and YouTube now, talking about blue forests and conservation and how science can impact that. So check out the Blue Ecology Science if you're interested in those videos. If you're interested more in the science, you can look up our Global Wetlands project. And finally, if you're interested in learning more about some of the tools we use, I'm a big proponent of the R program, and that's what I use to do all of my modelling and all of my GIS. And a lot of the tutorials I create, I make them freely available on my webpage, Seascape Models. So if you're in the phase of trying to learn about how to do GIS and spatial modelling, then please have a look at my webpage. So thank you very much for having me to present today, and I'll hand it back to Esther.
Chris, thank you so much for all the information that you share with us, and all the work that you are doing is very impressive, really, really. Well, example of this is that you allow us to visualize the information on a global scale. And I think that this helps a lot to highlight the power and importance of the HIS in the generation and management of the large amounts of information. So that brings the first question. And the first question is, in Mexico, the science is usually distant from the society, no? And the society is usually distant from the science. In your opinion, in Tasmania and in the rest of the world, is the same or is different? You have a different relation, like scientists with the people and the politicians and whatever?
Mm-hmm. Yeah, I think it depends where you go. So some universities are more traditional. We talk about the ivory tower. I don't know if you have that saying in Spanish, but the ivory tower is, where academics sit in a tower and they don't talk to the communities. So some places are like that. But the places where I've worked at Griffith University and University of Tasmania, people are very engaged with government and very engaged with non-governmental organisations like World Wildlife Fund. And so, we're doing a lot of work every day to engage. And I will say that the Mexican scientists I know, they're both in Australia now, Hiram and Fernanda, they are very engaged with government and communities in their research. So they're always thinking about, which Mexican communities is this work relevant to, and how can I help? How can this work help? On the ground with conservation. Thank you for the question.
Okay, thank you for your answer. Okay, we have time for one more question. If you want, you can leave some final comments. This is more technical question. How do you identify what information should be integrated in spatial analysis? This is because in other words, how you avoid problems of underestimation of the distribution of the species?
Yes, that's a great question. So the short answer is usually we're working with what information we have available. So for mangroves, there's great maps because you can easily see them from a satellite. There's great maps of where mangroves are and how fast they're being lost. So that's one of the first information sources we go to. Whereas for seagrass, we're much more constrained. Most seagrass grows under the water, so it's hard to map it with satellites or drones. So our maps aren't as good. So that does then limit and bias the information we have. And so, at the global scale for seagrass, our knowledge is much more biased to, North America, Southeast Asia, Australia, and Europe, where we have information. We don't know as much about Africa, for instance, about seagrass loss. So, we're always constrained by the data that's available to us. Thank you.
Okay, yes, you are right. No, the species is important and the knowledge that we have about. Well, Chris, thank you so much. You want to say a little bit more, or if not, we are really happy.
Yeah, thank you. Thank you for having me. It's a real honor to present.
You're welcome. See you and thank you.